Hi. So I am not John. My name is Reese Pearsall, and I am a teaching assistant for this course. And I will be filling in for John today, who is currently in Washington, D.C., doing some things. Um, if you can't tell already, this is not the actual recording from the lecture that happened this morning. Unfortunately, what happened is the server that the software uses to actually upload the video to, the servers were down, and so upload I wasn't able to upload the actual lecture recording from this morning. And so what I'm doing now is I'm just back at my home and I'm just giving the exact same lecture as I did this morning. And there really wasn't like a whole lot of questions or anything like that. And so I'm pretty much going to go over the exact same thing as I did in lecture. I'm going over the exact same examples and everything like that. Um, so yeah, that's that. And so today we are going to be talking about iteration, which is a really important topic in this course. But first, let's just make sure and check our understanding that we understand what we talked about on Monday. And so recall from last lecture that you guys learned about control statements, which is pretty much just these if statements. You had your ifs, your else ifs, and your elses. And we had learned about the Boolean statements like the double equal sign, the exclamation point equal sign, which is how you check to see if two things are not equal to each other. And then you have your different renditions of the greater than and less than and symbols. And then you also had the and or, which is kind of how you can check if both these conditions are correct, or if either or of these two conditions are right, or you can check to see if something is not true by using this not operator here. And I just wanted to go back over these because these are a super important concept in any programming language that you use. Every single programming language is going to have some kind of if statement here. And for pretty much like every future like lab assignment or like programming assignment in this class, there's a really good chance that you're going to use an if statement. And these are really important because they allow our program to make a decision for us. When we're talking about data and often like large sets of data, we often have to check for some value or some condition in our data. If we're searching for a value, we might have to check to see if the value we're looking at is equal to what we're searching for, or we might need to check to see if a value is greater than a threshold, something like that. It's a very common thing to do. And so these if statements are really important, and we're actually going to use them a little more today. Um, so if you don't quite understand them, I would say, check out the textbook, ask questions, talk to your teaching assistant, because we're going to keep pretty much using these if statements throughout the rest of the semester. Okay, and so moving on to today, we're going to talk about iteration here. And uh, so just like a basic overview is that oftentimes when we're programming, we want to repeat a certain portion of our code a certain amount of times, right? It's redundant to pretty much like copy and paste your code over and over again that does the exact same thing. If you're rewriting code that does the exact same thing as you already have, why don't we just repeat that code you have so you don't have to get this messy complex program. And so iteration allows us to like repeat the code, like I said, and make our solution more efficient and more like general for any kind of problem that's given to us. And so we call iteration kind of the structure, or the Python um, kind of structures. We call those loops. Okay, and you've kind of already been exposed to loops in some of the turtle graphics. And so the two loops we're going to be looking at in this course are going to be for loops and while loops. So I'm going to go ahead and open up Python here. Um, let's go ahead and just ignore what I have there. I was just testing some stuff out before I started recording. And so, like we did before in Turtles, we were kind of already exposed to for loops. So if we say like for I in range 10 and we print I, you notice that we print out 0, 1, 2, 3, all the way up to 9. So kind of what's going on here is we have this variable here called I. And I think John calls that the loop index variable. I just kind of refer to it as the iteration variable. So when I say iteration variable, I'm just referring to this variable here that comes after that for, and it's typically just going to be called I. We can certainly call this whatever we want. We could call it num up there and then call it num down here. We're going to get the exact same thing. It doesn't matter what you call this. Typically in computer science, the standard, if we're using a for loop, is just kind of the basic variable name is going to be I. I don't know where that came from, but if you look at other people's code, like maybe on the internet or like a partner's code, you're going to see this I loop a lot, and that's like across all the different languages here. Okay, and so we have this range function here, right? And so that will kind of give us kind of a list of all the numbers we need to iterate through from 0 to 9. One thing to note is that this stopping point, that 10 is not included in when we're printing it out, right? 10 was not printed out after 9. We only go up to 9, and then we stop printing. There's a few more things we can talk about here with the range function. One cool thing that Python kind of this idle environment gives us is if we type one of like the Python keywords for like a function that's built in, and we do an open parentheses, this box pops up and it kind of gives us some hints and some guidance of all the different input parameters that we can give this range function. So that first line just says that we can give it just a single number. We can give it just a stop, which is what we had before, right? We had that 10. That 10 represented that stopping point of the range function. And so that second line here is we can give it a start, a stop, and we can give it also a step. So let's take a look at that starting point. The word kind of speaks for itself. What that allows us to do is it allows us to give us a starting point for that range function. So if we wanted to print out all the numbers 5 to 9, we start off by giving a 5 and then a 10 for the stopping point. And you notice we start out at 5, 6, 7, 8, and 9. Looks good. The next thing is we had that step. We had the start, the stop, and the step. So like before, when I had just the 10, after each iteration, our iteration variable only went up by 1, right? We start off at 0, then 1, and then 2, and then 3. We only added 1 each time. And there's actually a way to modify this, and that's by using this step here. And so for this first input parameter, our starting point is going to be 0, and maybe want to go to 100. And if we do 10 here, that 10 is going to be our step, and we run it, we see that we start off at 0, and then 10, and then 20, and then 30, all the way up to 90. And so what's going on here is rather than going up by 1, we've given the range function kind of like how large of a step we want to go from the current iteration to the next iteration. So we want to go up by 10 after each iteration. So we go from 0 to 10, 10 to 20, increase by 10 each time. And maybe if I wanted to print out 100 as well, let's just go ahead and change that to 101, and we get 100. All right. That is the basics here with that for loop. Okay, so let's kind of use this range function here and maybe combine it with some if statements that we learned about on Monday and in the lab on Tuesday here. So how about let's print out the numbers 1 through 20 and determine if the number is even or odd. All right, I'll just leave that as odd. Cool. So if we want to print out the numbers 1 through 20, we can say for I in range. We can call it whatever we want, I, num, value, whatever we want. If we want to go from 1 to 20, and we want 20 to be included, then we have to go 1 above the kind of designated stopping point here. So we're going to go to 21. And we don't necessarily need to give it a step. That step is just optional because we want to go just by 1 each time, so we're not going to put a step in. So if I print out I, and I'm going to go ahead and just get rid of this part and run it, we see that we get all the numbers 1 to 20. So now we need to determine if the number's going to be even or odd. And kind of what I want this output to look like is I'll print out 1, and then on that same line I'll say is odd. 2 is even. 3 is odd here. Okay, so we're at a point now where we need our program to make a decision for us. We need our program to determine whether the thing we're printing out, is I an even number or an odd number. Okay? So before I do this, think about how can we determine if I is even or odd. So there's a couple ways we can do this. So like maybe how we want to structure this is we want an if statement that says if I is even, then we want to print out I and then is even. Something like that. And then we'll do the exact same thing down here, and we'll say like, else if I is odd, we'll say I is odd. Okay? So obviously this part of this statement right here, that doesn't really quite work here in Python. We need to kind of like, almost like mathematically kind of calculate if a number is even or odd here. So what I'm going to propose here, and this is a question I asked in class, is how can we determine if a number is even or odd here? So I'm going to kind of bring up something that I think John might have talked about in that first week here. One kind of operator, something like the plus sign, minus sign, the multiplication sign, is we have this modulus, all right, and that's the percentage sign right there. So if I say 5 modulus 2, what that does is that actually finds the remainder of those two numbers. So 2 goes into 5 twice with 1 remaining. And so that 1 is what gets printed out. If I say 26 modulus 7, we get 5 because 7 goes into 26 3 times, 21, so we have 5 left over. So 5 is what gets printed out. So how can we use this to determine if a number is even or odd? Well, if you think back to like the basic math and how we define properties of numbers, one characteristic that all even numbers shared is that all even numbers are evenly divisible by 2. And so what we can say is if I modulus 2 is equal to 0, right? So if there's no remainder when we divide by 2, that tells us that 2 was evenly divisible and it's even. We can come down here now and we can say if I modulus 2 does not equal 0, it's going to be the opposite. Then it's going to be odd. So if we run this, we get an error saying invalid syntax. So just take a look at where it's showing us. So we're getting it on this kind of calculation line here, and it's giving us invalid syntax. The reason for this is because we need to kind of remember the difference between a single equal sign and a double equal sign. A single equal sign is how we assign a value to a variable. We say I is equal to 4, or value is equal to 20, name is equal to Reese, so on and so forth. Double equal sign is what we use to check if two things are equivalent, right? If they have the same value. And if you're using if statements, you're pretty much only going to be using these double if statements, or these double equal sign, I'm sorry. Double equal sign should really only be used for if statements and for for a loop we'll talk about in a little bit here. So that's the difference here. We just had to fix that, and so if we run this now, here we go. So we get 1 is odd, 2 is even, 3 is odd, 4 is even, 5 is odd. Looks good. We can actually simplify this program just a little bit more here, actually. So what we can do is we can actually get rid of this, and we can just say else, right? Because another mathematical kind of principle is that a number is either even or odd. There's no kind of third option there. It's either even or odd. It's not both. So if a number is not even, then this else statement is going to get ran and it'll print out it's odd. Because that's like a mathematical law, right? I think if it's not even, then we'll print out it's odd because it can't be something else. Okay, that's just a way that we can simplify it here. All right, so we printed all the numbers 1 to 20, and we determined if it's odd or even. Okay, some more. I'm just going to comment this out now. Next thing we can do is if we have a string here, CSCI 127, it's a string because we wrap it in quotations, right? What we can do now is we can use a for loop to iterate through our string there. So we can say for each letter in our word, let's print out each letter. So instead of I used each letter there. Take a look what happens. What this for loop does and kind of how it interacts with the string is that it prints out each character of our string one line at a time. So first each letter was C, then S, and then C, and then I, and then space, all the way till the end of the string. Python knows that if you give it a string after the after you after this in statement right here, it knows that data type's a string, and so it's going to iterate through each individual character in that string. Okay. And so there's a lot of applications here. Like, right, we could maybe do like an if statement that will count like the amount of vowels or like maybe the length of that string. And I think John will touch on this on Friday when you talk about strings. I think that's gonna what the topic is that day. Um, cool. So that's just a really just basic overview of what you can do with that for loop there. One more thing you can do, and this is kind of jumping ahead to some stuff that you guys haven't learned yet, but I just want to mention this now because this is a really important application of for loops here. So far, we've only, like, if we have a variable here called value, we can only have like one value associated with it, right? We can only have 0 or 20 or like a word, Reese Pearsall. That's two words, but it's one string, right? It's one set of quotations. We can't have like so far we can't have values like 1 and 10 that we can only have one value assigned to that variable. One thing that you'll learn next week is there's this data type called lists. And so we have a list here called myList, and what we can do is we can give it multiple values in our list, right? So this list is kind of determined by these brackets. Everything that's in those brackets is what's going to be in that list here. So if I, um, print, like, first off, let's just print the type of my list. See what we get. We get it's a list like class object. So that's the data type of that. And now, um, if we just print out just my list, we get kind of just the bare bones raw kind of data in that list. So we can use for loops here to pretty much do the exact same thing as what we did with the string, is we can iterate through each individual kind of data value in our list. So we can say for each name in my list, let's print each name. And we get each kind of individual name here on its own line. This for loop where you iterate through a list is something that you'll be doing, I think, in a lot of the programming assignments this semester. It's a very common thing. For loops and lists are like peanut butter and jelly. They just go together like super well. And one thing I will say is that, like, why didn't I call this I right here? One thing I like to do is I like to look at like what exactly is in our list. So we have a list of names here. So I said the name of my iteration variable was each name. That just kind of helps me kind of understand like what is actually like in the list and like what I'm printing out or like what I'm checking here. Because we could totally put an if statement in here and we can check to see like if each name is equal to like Reese, double equal sign here, right? Um, and then we could say it's like we could print something out and it says like Reese detected, something like that. There's a lot of things we can do here. It's a very powerful kind of resource. And you'll learn a lot more about lists next week. You'll learn a lot about them this semester. Um, but that is the last thing that we're going to talk about on for loops. All right, so like I said, we have two different loops here. We have the for loop, and the second loop we had was the while loop. And each of these loops kind of has its pros and cons. So kind of difference here is we used a for loop to repeat code like a certain number of times, right? We repeated that code 21 times, right? We had 20 numbers, and so we ran this exact same code on each number to check to see if it was even or odd. If you know how many times you need to repeat your code, like if you want to repeat your code 10 times or like 50,000 times, hint hint, program one, a for loop is what you can use there because you know how many times you want to loop. A while loop is what you can use if you don't necessarily know how many times you want to repeat your code. We might want to repeat our code for forever, right? We might want to repeat our code like until the user like exits our program or exits our app or whatever we want. So here's just a quick example here. So I'll initialize this variable x to be 0. And we're going to say while x is less than 20, we will print x. And after we print that out, let's just increase x by 1. Let's see what we get here. So what's going on here is this. You can kind of tell this is what we've done here is kind of similar to the for loop here. And there's kind of some overlap between for loops and while loops. But the difference here is that we have this condition that we kind of loop on. So each time we iterate, each time we come back up to the top, we check to see this condition. If that condition is true, then we're going to execute all the code that's like indented in this while loop here. So we printed out all these numbers and we got to 19 down here. We printed out 19 and, or sorry, let's rewind just one more step. We printed out 18 and we increased x by 1, so x is now 19. And we repeat back up here, and so at this point x is 19, and we check to see, is 19 less than 20? It is, right? That's true. So we're going to keep on going. X gets increased one more time, so now x is 20. We repeat once more, and so now x is going to be 20. And we check to see, like, is 20 less than 20, right? That evaluates to be false, right? Because we do not have that equal sign right there. If we had that equal sign, then it would go once more. But at this point, it gets to 20, and this condition is no longer true. And so we exit the loop. That's kind of what we're doing here. We have a condition that we constantly check each iteration, and if that condition is ever false, then we stop looping here. All right. Now, one spooky thing here is if you're using while loops, one thing you could run into is you can get stuck in an infinite loop here. So let's take a look at example. We're going to do something very similar, but we're going to change our condition here. Our condition we're going to loop on is we're going to check, is x greater than or equal to 0? That's the condition we're always going to be checking. So before I run this, think about what might get printed out here. So if we run this, we get a lot here, right? This is an infinite loop because it keeps on running, and this is going to run for forever. If we take a look at why this is happening, right, we initialize x to be 0, and so we check to see, is x greater than or equal to 0? Which this is true, right? We're going to run this code, and then x gets increased by 1 each time. So our x is going to keep getting bigger and bigger, and this condition is always going to be true, right? Because we're never going to get like a negative number like that. X is always going to be greater than 0 because we're adding on a positive number. And so this is going to run for forever, and this is probably going to happen at some point in the semester where we just start looping, and it's not going to stop for a long time. I would say generally it's probably not very good for your computer. And so what you can do is rather than just like closing Python, if you do Control C, there we go. Control C is what I did, and that's a keyboard interrupt. So it's just going to terminate whatever like program is running, and it'll just stop it. On Mac, I think it's going to be like the equivalent, like the Command C, I think it is. I'm not quite sure. But that's kind of just a shortcut of how you can just stop it. Because there'll be times in the semester where you just kind of mess up and you just get stuck in this loop here. If you do get stuck in an infinite loop, you should look at your condition that you're looping off of and like make sure that how you're like evaluating that like makes sense and is correct. If your condition is not correct, then you might just loop for forever here. Okay. So that is the basics of the for loop here. I'm going to show you a a diagram here. I'll just leave it like this. So this is a basic flow diagram of how a while loop works. So we start off um, at this diamond box here, and we check to see is the condition true, right? The condition is what was in our parentheses. This is our condition. If that condition was true, if yes, then we're going to evaluate every statement in the body of that loop. So everything that was indented in that while loop. If it's not true, then we exit the loop. All right, that's just a basic overview, and I got this image straight from the textbook. Okay, so now we're going to move on to some active learning here, and I'm going to go ahead and pull up the notes for today here. Just a second. Okay, so let's see, September 11th here, and if I drag this over and increase it, well, we're going to do some active learning here. So, so I guess before I do this, there's a couple more things we need to talk about, and that's going to be the continue and break statements here. So I'm just going to hop back to my code here and do this one last thing because I think it's kind of important to know what these keywords do here. So we're going to do just this basic for loop here. We're going to say for I in range 10. If we print out I, right, we know that that's going to print out 0 to 9. So how about like what I do here is if I say, if I is equal to 5, then let's break. And then we'll just print outside our if statement. If we run this, let's see what we get. We get 0, 1, 2, 3, 4. So what happened here, what's going on here is that we reach this if statement here. Once we get to 5, we check to see is 5 equal to 5, which it is, right? So we're going to execute this break statement. What this break statement does is it just exits the loop you're currently in. So we got to 5, and so we break, and we exited this for loop, and we didn't print out anything else because our program was done. So that's just a way, if you need like an easy way to just straight up just like get out of the loop, break is what you can use. If we use continue here, we get something a little bit similar here. So we get 0, 1, 2, 3, 4, 6, 7, 8, 9. So 5 was not printed out here. And it's kind of the same thing here. I don't know why I had a semicolon there. If we continue, what that does is it exits the current iteration that you're in, but keeps you going in the loop here. So when we reached I is equal to 5, we continued, and so this print statement didn't get ran because we went back, we repeated the code, and so we went back up to the top of the for loop here. So break will just straight up exit the loop. Continue will exit the current iteration you're at, but will keep you inside the loop. And so it's noted here that try to avoid using these two Python constructs. Typically, there's a better way to solve the problem. I mean, they're there. Generally, yeah, if you are using them, there's typically a better way of doing the problem. You can use them. I don't know, you probably won't get points taken off, but it's just a good practice, and it's a better way to problem solve if you don't use those. But I just want to point those out because those are two important concepts in iteration here. Okay, active learning time. So we're going to do both of these active learnings, and we'll call it a day. So this first one here is we're going to write a Python program that generates a random number between 1 and 10. The program should repeatedly ask the user to guess what the number is until the user guesses correctly. When the user guesses correctly, the program should print a message that shows how many tries it took. For example, the message, "Congratulations, that took 6 guesses," might get printed out when we guess the number correctly. Okay, so how about let's kind of start off by solving a smaller problem here. Let's first just, the program should repeatedly ask the user until the user guesses correctly. Let's worry about that first, and once we solve that, then we can add on the counter for how many guesses it took. Okay, so before we get started, there's a couple things you should look for here that kind of gives you just like a starting point of what you need to do first. So I'm going to comment this out, and let's start here. Before we start, think about what we need to do first. This is where I ask the class, maybe what's going on, but since I don't have a class in front of me, I'll just kind of answer it for you. So you notice that we need to randomly generate a number between 1 and 10. And that tells me that the first thing we need to do is import the random module. That's what allows us to generate those random numbers. And so if we want to generate a random number between 1 and 10, we can create a variable here. I'm going to call it the answer, right? Because that's going to be like the answer they're trying to figure out. And we'll say answer is equal to random.randint. And if you notice, that yellow box pops up and it says, we can give it an A and the B, and it's going to give us a random integer in that range, including both of the endpoints here. So this is going to be a little different than the range here, right? Because both of the endpoints are going to be included here. So if we want to go from 1 to 10, that's what we're going to plug in. Okay, we got the random number generated. So now what we need to do is we need to prompt the user for a guess. So we'll say like guess is equal to input, and I'll say like, your guess is, and then they'll enter their guess. Okay? And so maybe like, what's the next thing we need to do here? Spoiler, we're gonna need to use something that we just talked about. We need to use a loop here, right? Because we need to repeatedly prompt them for a guess until they get until they get it correctly here. So should we be using a for loop here or a while loop here? Think about, do we know how many tries it's going to take the user to get the right number? We don't really know. It could take one guess, it could take 10 guesses at the most, but maybe if they're just like smashing their keyboard, it might take like 50 guesses. Yeah? So we don't really know what the number of times we need to keep prompting the user for. So that tells me that we need to use a while loop here. And so we'll say like while, and we're going to keep this guess in that while loop because we want to keep repeating that. And so our condition here is we want to repeat as long as their guess does not equal the answer. So if their guess is not equal to answer, we're going to keep prompting them. If they get the right answer, so if guess is equal to answer, we're going to exit the loop and it'll print out, congratulations, you got it. Okay, so, all right, yeah. So if they get it right, the loop is going to exit and it'll print out, you got it. And we'll add on to that later. All right, so if we run this, we see that we get an error here, and we say guess is not defined. So let's try to figure out what's going on here. So we're getting it on this while loop line. So we're getting it up here. So think about why we're getting this error here. Remember that Python kind of reads this from top to bottom here. So when we get to this while loop, we're going to check to see the value of guess and the value of answer. We're going to compare them. The thing is, at this point in the program, guess is not defined yet, actually. Guess is defined down here, and so when it looks for the value of this, it can't find anything because there's no value for it. So what we need to do is we need to just say guess is, we're going to initialize it to be 0. 0 is just a safe number there, right? Because that guess is not between that range of 1 to 10. So this is a little bit unrelated to the problem at hand, but whenever you get like this is not defined, the name error, I would say the first thing you should look for is if you have a typo in your variable name. It's very easy to switch around 2 letters or like have like an uppercase in there somewhere. That will throw it off totally. And it totally will save you some time because I'd say like 60% of the time when people get this bug and they come to me, usually it has to do with just a typo, and it sucks when you have been debugging it for like an hour and it just turned out you spelled tax wrong or something like that. That's the first thing I look for. And if that's not the case, then I'd say look at where your variable is defined and um, make sure that at the point in that code where it's airing out at, make sure that the variable is defined there before you reach it. Okay, yeah, that's just my unsolicited advice there. Okay, so I guess before we actually run this, I'm going to cheat a little bit, and I'm just going to print out the number we randomly generated. And if we run this, so the number we randomly generated is 7. Okay, so if we say like 1, it's going to prompt us again. 2, it keeps going until we get to 7, and we guessed 7, but we keep the prompted us for a number again, and so it looks like that's not really supposed to happen here. If we said 7, then it should exit the loop here. And so we have a problem here. And this is kind of the part of debugging that's kind of tough here, is when it doesn't give us one of these error statements. We're getting like a code that doesn't, we're getting an error that doesn't quite like air out. And so let's think about what could possibly be going on here. So since we keep on looping, the problem is probably going to be in our condition statement. And so let's think about the data types that we're comparing here. So answer is an integer that we randomly generated. This gives us an integer right here. Guess is actually going to be a string. That's because we use input, and remember by default that it's going to be a string by default. So we need to change this to be an integer. We can't compare strings and integers. We need to compare things of the same data type. So now we're comparing integers to integers. If we run this now, so the number randomly generated was 8. Let's just make sure it keeps prompting us for incorrect guesses. And then if we get 8, then we got it. Okay? So make sure that, does this make sense to you? Why we want to use a while loop here, and like what we're kind of looping off of? So let's implement the second part here. Is we need to keep track of how many guesses the user has currently done, and then print that number out at the very end. We'll say, congratulations, that took blank number of guesses here. Okay, so this is a pretty basic kind of addition to the program. What we can do is, if we want kind of like a number that will kind of act as a counter, let's create a new variable. We'll say like num of guesses, and we'll initialize it to be 0. And after we prompt them for a guess, let's increase that counter by 1. So to do that, and hear me out on this, we'll say num of guesses is equal to num of guesses plus 1. Okay? So we'll take the previous value of the number of guesses and just add 1 to it. That way, we can kind of just keep adding 1 and kind of keep building up gradually over time. Okay? This is just a basic way of how you can make a counter here. And actually, there's a more shorthand way of doing this. Instead of saying num of guesses is equal to num of guesses plus 1, we can say num of guesses plus equals 1. That is going to be the exact same thing as what we just typed. It's a shorter way of doing this. And this is like another thing that you'll be doing a lot, because you'll need to keep track of like a counter of some kind in a lot of the assignments. And so this num of guesses, the plus equals 1 is a really kind of thing you'll be doing quite a lot. And it's just important thing to understand what that plus equals does. Okay, so we increase that counter by 1 for each guess. And so after we exit the loop, let's go ahead and say, like, you got it. That took, I'll say, comma, num of guesses, guesses. Run that. And so let's see, our random number was 3. So we guess 2, 6, and then we do 3. We should get, that took 3 guesses. Cool. So let's kind of try this legitly now. Let's not print out our answer and kind of do this blindly and see how well we do. Okay, your guess, let's guess 5. Oh, okay, and we got it in 1 guess. That is some really good luck, or maybe I'm really skilled. Let's try it again. So let's try 2, 8, 5, 1, 3, 4, 6, 7. Okay, 7, and like, we can count this up. That took 8 guesses here. Okay, we are done, right? This looks good, yeah. we're using a while loop, and we're going to keep looping and keep prompting for the keep prompting the user to enter a new guess. Okay. The next thing is going to be the second active learning, which is going to be we're going to write a Python program that asks the user to enter two integers, one for the number of rows and one for the number of columns. The program should then produce a text-based drawing where each position in the drawing is randomly determined with an equal probability to be either a star or a dash. For example, of 4 rows and 6 columns, it might look like this here. So we kind of have like this matrix or like this grid here that's filled up with either stars or dashes, and it's going to be random each time, and it's going to be an equal probability of whether like each symbol is going to be a dash or a star. Okay, so we understand the task at hand, and I'm going to say again is let's try to solve a smaller problem. Maybe let's try to just try to generate just one row. And if we know how to generate one row, then maybe we could repeat that process for another 3 times, so we get to 4 rows. Okay, let's go back to our code. I'm going to comment all of this out. Now, start a new program here. So let's think about maybe we need to do first as just like a starting point here. So let's first, I guess, let's prompt the user for 2 inputs here. So we'll have a variable here called rows, which is going to be an integer, and we're going to say like enter number of rows. Oops. Enter number of rows, and we need to cast it to be an integer. I'll point that out later why. And we'll say columns is equal to integer inputs enter number of columns. Okay, and so what we need to kind of think about is like how we can like equally determine if a symbol is going to be a star or a dash with an equal probability chance. So you might not, the answer for you might not come right away. And so how about is we're actually going to use the random module again, okay? And how about let's generate a random number random int, and let's generate a random number between 1 and 2. And remember that both of these endpoints are going to be included. The number we generate is either going to be 1 or 2. It's going to be a 50-50 chance, right? And so maybe we can look at what this number is, and if it's a 1, we'll do a star. If this number is a 2, we'll do a dashed line. That way it gives us an equal probability of either this if the symbol is going to be a star or a dashed line. Okay. So now let's take a look and let's say like, if the random number, random is equal to 1, then we'll say like maybe we'll put a star here. If else if the random number is equal to 2, then we'll associate like a dash with that. Okay. So we've used some if statements here, we use some user inputs and some random. We're missing like a thing here, and like before, we're going to need to use a loop here, okay? So we have a for loop or a while loop. So let's think about maybe how we could use those resources to help solve this problem here. Okay, so this code right here will generate, it will help us determine if a single symbol is going to be a star or a dashed line, okay? And if we want to repeat that process for however many symbols we have in a single row, right? That because we're solving just a single row for right now, and then we can worry about everything else later. Okay, so we need to repeat this process 1, 2, 3, 4, 5, 6 times. We want to repeat that 6 times, which represents the number of columns. If they want 10 columns, then this is going to be a little bit longer, and we want to do this process 10 times. Okay? So how about, let's use a for loop here. We'll say for I in range, and we want to do this for however many columns they want, okay? And so I had to cast columns to be an integer up here because we're using it for a range function right here. Okay, so we're going to indent this code so it's now part of the body of this for loop. And so, like maybe, like just like right now, let's just print out a star, and we'll do a print for the dashed line as well. Let's take a look at what we're getting. And I forgot my colon. And so let's do 5 rows and 5 columns. And so let's take a look at this. We're printing it out 5 different symbols here because we wanted 5 columns. We're getting a star, a dash, and a star. That like represents a single row, but at this point, it's only printing out each symbol on its own line, and we kind of want to just like kind of combine them together on a single line per se. Okay? If we can do that, then we've solved it for a single row. And let's just verify that if we run this again, and we do the exact same thing, we get a different kind of output here, which is good because we're randomly generating this kind of output per se, right? So let's worry about trying to get all these symbol onto one line here. And there's a few different ways you can do this, but I'm kind of gonna try to propose a way to you, and I'm kind of just gonna show it first, and I'll try to explain this along the way. So let's initialize a new variable called row text, and we'll initialize it to just be an empty string, okay? And what this variable represents is this going to be kind of the string for just a single row in our matrix or in our grid, we can per se. So how about instead of printing this out, let's concatenate. We'll say row text is equal to row text plus star. Okay, so we're adding 2 strings to each other, so we're concatenating those together. So it's pretty much going to take 2 strings and just smash them together into one single string. So we can do the same thing down here. Row text plus dash, and so like maybe to verify kind of and see how our row text kind of like building over time. Let's print row text out in our inner loop here. Okay, so we'll do same thing 5 by 5, and okay, we're getting an error here because I kind of fat fingered my my space bar there. So we'll do 5 by 5, and okay, so let's take a look here. So here we're printing out row text here, right? And so we first start off with 2 symbols, we start off with 1 symbol, then we go to 2 symbols, 3, 4, all the way up to 5. And we kind of keep progressively adding on a new symbol in each iteration here. So by the end here, so if I take this print row and I do it after we've gone through all the iterations of our for loop, we run this 5 by 5, we get a single row. Does that make sense? And so we can actually kind of before, instead of saying row text is equal to row text plus something, we can say plus equals, and that will do kind of the same thing as before, but we're concatenating strings this time. Okay, so the idea here is we keep kind of building on the string, we keep slapping on a new symbol each time until we have our final product, and we print that guy out at the end of our for loop. Okay, we have a single row, but now we need to do that another 4 times, right? Or for however many rows they want. This is a single row. If they want 4 rows, we need to do 3 more. Okay? think about how maybe we could do that. So we have the code that will do this. This code right here will do it for a single row, right? So if we have it for a single row, let's just repeat that for however many rows they want, okay? So what we're going to do is we're actually going to do another loop. We'll say for C in range rows, we're going to repeat all this code again, all right? This is a little bit confusing, but I'll explain this in a second here. So if we get this, we'll do 5 rows by 5. If we take a look at our output here, we're getting something a little bit strange here. And so if you actually like look at how long the string is, this is actually going to be 25 characters long. So we kind of keep building on and on and on. We never like reset the row text, okay? And that's a problem here, right? When we repeat this code again, row text still maintains its same value. We never reset it. So what we can do is we can actually reset it. We'll say row text is equal to blank, and actually I think if we get rid of that up here, it'll get rid of some extra code. We'll do 5 by 5. Take a look at that. There we go. We're getting kind of something we want here. And maybe let's do like 25 by 25. There we go. We get a large matrix, 25 columns by 25 rows, and we get an equal probability of stars and dashes here. Okay, so what we did here is we actually put a loop inside of a loop, which is kind of like a really confusing concept to think about, right? But this is like a common thing we do in computer science. We call this nested loops. It's where you put loops inside of each other. So here we put a for loop in a for loop, and like you can totally have like a for loop in a while loop, or a while loop in a while loop in a for loop, whatever. And you can keep kind of nesting loops inside of each other for however many times you want. But the thing is, right, the more like nested loops you have, the more complicated and confusing your code is going to get. So like I would say, if you have like more than 4 loops nesting inside of each other, you're generally maybe like overthinking the problem, or you might need to like take a step back and kind of think of maybe like an easier way or like a more efficient way of doing it, just because it gets really just like terrible the more loops you have inside of each other. Okay. I think we're just about to the end here. Oh yeah, we're a little bit over here. Okay, so we're done for this guy, right? Hopefully that makes sense. So just to wrap things up, we went over um, iteration here. And iteration is simply just a way to repeat code. And we learned about 2 kind of constructs in Python that allows us to loop. We have for loops, we have while loops. We use for loops to iterate through code that if we know like how many times we want to repeat the code, then we use for loops. If we don't know how many times we want to loop through the block of code, we're gonna use a while loop generally. And so we learned about the differences there, the pros and cons, infinite loops. We learned about the break statements, the continue statements, how we can kind of combine if statements into loops, and how we can actually nest loops inside of other loops here. So that's all I really have for today. Thank you for watching, and I apologize that this wasn't like the actual lecture, but I promise you did not miss out anything important. What I just went over is the exact same thing I went over in lecture. Okay, so now you have all the resources to start on program 1, which is going to be due on Wednesday the 18th at 11:58. You'll be using loops there, and I will be holding a program help session for program 1 either on Tuesday or Wednesday. I'm going to announce that this weekend on D2L. And so that help session is there for you if you get stuck on a problem or a bug that you just don't know how to fix. You can come in and get help. If you just don't like really know at all where to start, or you're just totally confused, you can totally come in and get help. Okay, so thank you for watching. John will be back on on Friday. If you have any questions about loops or iteration or any of the code we talked about, you can send me an email through D2L. Yeah, thanks for watching and have a good rest of your day.